Good morning. This is Unit 3, Algebra 1B Part 2, Unit 3, Rational Expressions and Functions. Lesson 4, Adding and Subtracting Rational Expressions. Okay. As mentioned before, a rational expression can be interpreted as fraction. Rational means fraction, a ratio of whole numbers. Okay. And so when we add and subtract fractions, we need to remind ourselves of some of the things that we did. Let's do 3/8 plus 5. No, let's do 3/10. 3/8 plus 3/10. Okay. I'm going to show you a technique for doing this involving factoring, because that's going to relate to what we're doing here. Okay. 8 happens to be 2 times 2 times 2. That's the prime factorization of 8. 10 is 2 times 5. Okay, so what I want to do is I want to get a common denominator. And one approach to doing that is to multiply the top and bottom of both fractions by the factors that are missing out of the denominator. 2 and 5. Well, this denominator has a 2, but it has 3 2's, so I'm missing 2 2's. So I'm going to multiply this side by 2 2's. 2 times 2 on top and 2 times 2 on bottom. On this side, we're missing a 5, so I'm going to put in a 5 here. Now, the list of factors match in the denominators. 2, 2, 2, 5, 2, 2, 2, 5. Okay? And that will get me a common denominator. 3 times 5 is 15. 3 times 2 is 6 times 2 is 12. And the common denominator is 2 times 2 times 2 times 5, which is 8 times 5, which is 40. And 15 plus 12 is 27/40. Okay? So a little bit of reminder of how to add fractions using this technique. Now let's apply this to a rational expression with variables. Let's do x plus 2 divided by x minus 4 plus 3x divided by x squared plus, let's see, actually let's do minus see, 24 okay, yeah, I'm just thinking here for a moment. Alright, I had to make a problem that works. Alright, so here we go. So 3x over x squared plus 2x minus 24. Okay, so I'm going to do the same thing I did before. I'm going to factor what I can factor. So x plus 2 over x minus 4 plus this factors. So I'm going to write a pair of binomials. X times x is x squared. And I'm going to think of things that multiply to make 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And I need a pair that subtract to make 2. That's going to be 4 and 6. And they subtract to make positive 2 if the 6 is positive and the 4 is negative. Okay? So there we go. It's factored. All right. So now, look at the problem on the left and let's see what the next step is. The next step is to multiply top and bottom of both fractions by the factor that's missing. Now here I have an x minus 4 in the denominator. Here I have an x minus 4. So it's not necessary to multiply the right-hand one by anything. But this one is missing an x plus 6. So I'm going to multiply x plus 6 on top and bottom. Now you'll notice both denominators match. Okay? Both denominators match. All right, so now I can multiply things out and distribute. So I'm going to get x squared plus 2x plus 6x plus 12 plus 3x, the 3x came from over here, all over x plus 6, x minus 4. And I could multiply out the denominator. And now we regroup, that it means combine like terms. So x squared, 2x and 6x is 8x, and 3x is 11x plus 12 over x plus 6, x minus 4. Okay? And that is added. So we just added these two fractions, these two rational expressions, into a single rational expression. Now it might be interesting to see if this factors and if there's any reducing. I don't think it does. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. We need factors that add to make 11. Nope, none of these add to make 11, so that's a dead end. All right, so that would be the answer. Okay. Now that said, what if we change the problem to a subtraction problem? What if we change this to x plus 2, x plus 2 over x minus 4 plus, or not plus, but minus 3x over x squared plus 2x minus 24. Okay. Well, the answer to that is actually fairly simple. Okay. When I write a fraction like negative 2 over 3, that can be negative 2 over 3. That can be 2 over negative 3. That can be negative 2/3. The negative can go in any one place, not two, but any one place. So let's take this negative, turn it to a positive, and put the negative in front of the 3x. So just changing the sign on the numerator is the same as adding a negative. Because remember, when we subtract, if I had 4 minus 5, that's the same as 4 plus negative 5. Adding a negative is the same as subtracting. All right.